Welcome everyone. Thanks for tuning in for the Thriving Through the Decade of Disruption, the innovation series done by the University of Queensland Business School. So my name's Cameron Turner. I'm the entrepreneur in residence in the business school, and what these series are really about is discussing with innovators and thought leaders and entrepreneurs, researchers around how can we help to embrace and leverage and liberate value as a result of going through this COVID disruption. Because what we know is that everything is changing. And while disruption has always been a face, it's actually accelerating. And so in some ways, I guess what this series is about is exploring how can we put ourselves, in the best position to be able to come out of this. It's often called the Great Reset is what we need. The World Economic Forum referred to it as the Great Reset. How do we use this as an opportunity to actually reset how we do business, how we do research, how we do innovation, and how we do economic development. So today I'm really excited to have Professor Neena Mitter. Neena is a good friend of mine. We've known each other for a long time, and Neena is the director of the Horticulture Centre, or the Centre for Horticulture in the Queensland Alliance of Agriculture and Food Innovation. And so Neena runs this centre, but she's also a very well-established researcher in her own right. In some ways, I'd describe her at least as an entrepreneur within the university environment. She's been tremendously successful in some of her research in the agriculture and horticulture field. And so Neena, just as we get started, maybe if you can tell us a little bit about some of the research that you're doing, and particularly excited around some of these really quite transformational innovations that you've identified, and really interested in how you see this change that we're probably just going into in the early stages, and what excites you around, even though it's a real crisis, but what excites you, or what do you think are the challenges and the things we need to embrace to really try and leverage innovation in a way that we haven't been able to do before, and maybe using some of your own research as some examples of that?
Oh, thanks, Cameron, and thanks for this opportunity, and my hello to everyone who has joined this webinar. Thank you. Food security and nutritional security, Cameron, is not something new. We have been talking about it. If you look at any publication over the last 5-7 years, the first statement mostly will be, 10 billion people walking on planet Earth by 2050. But what we forget sometimes is that 820 million people still go to bed without food. And of these, 135 million actually suffer from acute hunger. And what this COVID-19 and this pandemic, because that's the relevance of today's talk, has done is, if you look at the FAO report of July 2020, this 135 million acute hunger figure will double by the end of this year. So we would have 265 million people acute hunger problem. And this is what sort of brings me, because you've been asking about my motivation and how we see the innovation web weaving into this equation. I think it's absolutely an inflection point at the moment. And we need to start those new conversations, which will reflect upon not only how we produce food, but how we supply food, how we consume food, how we perceive food, and the link of food with health, and the definitions that are changing. The definitions of supply chain is changing, the definition of border is changing, local, national, international. So in this context, I think innovation becomes a really critical factor. And for me, Cameron, innovation has been I always say agriculture is in my DNA, and so is innovation, grounded in me by my Indian heritage. When I was growing up, we were refugees from Lahore, moved to Delhi when India-Pakistan divide happened. And my grandfather brought me up with stories where food was the central focus. That food on the plate was something absolutely critical and important. And that's remained with me growing up, that's the core. And that's where my innovation sits as well. So I am motivated. I'm to work, where anything that I do should have an impact on the ground. That's always been my focus throughout my career. I cannot work if I'm bound by silos. So most of my work has been cross-disciplinary, across disciplines, across boundaries, across organizations, across geographies, with the key motivating factor that anything I do should create a change, but create a change that counts.
Yeah,
So sort of that's where I come from.
that's great, Neena. And what I'm one of the, I mean, you've got a number of technologies that you're developing, but I think there's a couple that are particularly exciting and particularly interested in the Bioclay sort of research invention and how that's gone, because that was, you know, and talk us through a little bit about how that happened, because it is potentially a really quite profoundly transformational idea and technology and discovery that really could have a big impact, you know, in agriculture and in food production. So I love you've set the scene around what is your why, and I think that's so fundamentally important to understand where is the why coming from. But so tell us a little bit about the what and the how. How are you actually? How are you? What role do you see yourself playing, and where does this technology fit into that? Tell us a little bit more about Bioclay and so even the micropropagation process you're doing.
Maybe let's start with Bioclay. And you mentioned, you know, in your introduction, the word reset, and pivot is another word which is being used most commonly these days. So Bioclay actually happened as my thinking. You know, you need to pivot to the changing needs. So when I moved to Australia in the year 2000, I was working on gene silencing or RNA interference. And the whole rationale was to develop genetically modified crops which are resistant to pests and diseases. Did that, worked well, but very soon realized that there was no industry uptake or appetite for a GM food crop, and it's still a challenge. This is where I did that pivoting and thinking of, you know, delivering RNAi or RNA interference for crop protection in any other way, which may help me to reach that adoption and acceptance by the community and the society and have the outreach. The triggering factor Cameron, there was that there was a news article actually, which to me, I still won't, you know, forget that image in my head, which said 26 children in India died after consuming a community meal that had toxic pesticides. And I thought, look, we have this wonderful technology called RNA interference. We can really use it to protect crops from pests and diseases in a sustainable manner. Why can't we have a technique which would be much more acceptable? And that was sort of the genesis of this Bioclay platform. I was giving a lunchtime seminar, just like this webinar today, and I was saying RNAi, where double-stranded RNA is actually the active ingredient. So in a GM crop, what we do is we express that double-stranded RNA in the crop so that the plant is making that double-stranded RNA, which is a pathogen-specific double-stranded RNA. And I was thinking, why can't we just spray this active on a crop rather than making it genetically modified and have it as a biopesticide? Professor Max Liu was hearing that talk that day, and he's a nano engineer and a nanomaterial person, came to me and said, how about let's have a chat, maybe I can give you a delivery vehicle which would be nice to deliver this double-stranded RNA. And that's where the word Bioclay was coined. Bio is the active or the biological, and clay is the, I call it, very fancy delivery platform. Because if I deliver this active without my postman or without the clay particles, the naked RNA is very susceptible to, environment and UV rays and degradation. It won't last on the crop for more than 3 to 5 days. Whereas if I deliver it using clay particles, we get a longer term protection. So that's a little bit of the science on Bioclay. But let me talk you to the pathway as you were talking about how it all happened. So I'm a person who is always engaged with the industry right from the inception of the idea. So it's not that I go to industry later on when we need funding or we need grants or there is a deadline there to submit that application. For me, industry partners become very much a part of the team. we grow together, we develop the idea together, and therefore we are there to see the translation together. And that's what happened with Bioclay. Initially, of course, the first sort of steps were helped by Bill and Melinda Gates Foundation. So when I had this idea, talked with Clay, as it happens, sometimes you get these opportune moments. So there was a Bill and Melinda Gates Grand Challenge round going on. We submitted them this 2-pager of an innovative idea. That's all they needed. The best email I ever received in my life. They said, they had 2,700 applicants. They selected only 23 innovative ideas and only one in the space of agriculture that year from Australia. And the best line in that email was Cameron saying, and now we would like to know your CV and your organizations, because we want to make sure that you're not operating from a garage and you can actually do the research.
Yeah.
And it was not big money, $100,000, but from that team of 3, myself, Professor Gordon Zhu at AIBN, Australian Institute of Bioengineering and Nanotechnology at UQ, and a postdoc, we are now a team of 50. We have a commercialization industry partner. From that 100,000, we are now $30 million. And recently we got the Australian Research Council Hub to take this Bioclay innovation platform for developing sustainable solution to protect crops from fungal diseases. So I'm happy to answer here more on Bioclay, sort of how this.
Yeah, look, that's and look, it's a great way to have this conversation, because what you've done is you've juxtaposed 2 fairly similar technologies, GMO technology and this RNAi interferase, and one they both offer really great potential, but the GM technology offers profound potential, but it really hasn't materialized as much as everyone would have hoped to. In some ways, even though the technology works and most people that know about GM know that it's safe, but ultimately the consumers weren't prepared to accept the risk, and therefore the representatives of those consumers weren't. And so it's sort of this really interesting situation that the researchers often find themselves in, is that they solve the right technical problem, but perhaps solve the wrong actual market-based problem. And so that's why I love the fact that you've introduced it that way, because GM, great technology, but really poor adoption. And so what you've done is you've taken the best out of that and applied it in the sense that actually removes that risk. And so therefore, from a consumer point of view, it really has the best of both worlds. It has a transformational, I guess, improvement in safety as opposed to a risk of safety, but then offers the farmer as well. So the farmer and the consumer both benefit. So tell me about how you're feeling about the willingness of industry to engage with this technology, because they've been very unwilling to engage with GM. How are you finding industry relating to this sort of technology?
So coming back to your GM thing, with genetically modified one, you have protection for life. So, absolutely wonderful platform. For me, it was one thing was the community acceptance, but some other inherent factors were also there. Some technical things, if you are going to make a genetically modified crop, you cannot do it at ease with all the crops. You can do it with tomato or capsicums, or where easy transformation protocols are available. But when you look at broader sector of horticultural crops, tree, especially avocados, and we'll come to that later on, you cannot even genetically modify all crops. So there is that bottleneck also there, and that long pipeline also there. And another way with this virus now happening, which I think I would like to mention also, that pathogens evolve. As we know, this virus the COVID-19 has so many, mutations, and we are doing genomic sequencing to know the strains. Pathogens evolve very quickly as well. So they mutate, they change. If we are going through the genetically modified pathway, sometimes it becomes very difficult then to go through that long pipeline. So for me, this Bioclay also offered this advantage that if tomorrow the virus is changing in a sequence, we can just change the dsRNA sequence and have another spray ready. So, all sort of that sort of factors also coming into the question. Now, in terms of industry uptake, I also rely very heavily on communication and outreach. And communication and outreach and training my staff and students as well to be bilingual. They're multilingual, but bilingual in terms of be able to present to academia and science, but at the same time to be able to talk to industry and the growers and the farming community in a language that they understand. And another ethos I think we follow in my lab is we go to the growers or the industry and farming community and stakeholders not as educators, but as the way we are having a conversation, a two-way process, where very respectful two-way process where we are not saying, oh, this is what we have and this is the best thing, and this is what you need to do, but learning from them about their concerns and then slowly weaving that way through. And this has really helped me in making this Bioclay. I am very pleased to say, that I get calls from growers offering me their field trial sites, saying, would you like to come and try your Bioclay delivery method? So that is one aspect. But the second aspect for me with Bioclay has been, and I must mention that, like when I started this, I was saying it is non-GM. I was saying, look, we are just spraying the dsRNA, it's not getting integrated into the plant, but there is this word gene technology and there is this word RNA. And it took me several trips to Canberra, but Office of Gene Technology Regulator last year passed in its legislation that topical application of RNA or RNAi will be considered as non-GM. So that was a nice, sort of confidence building step as well with the industry. So engagement, communication, strong partnership, and keeping the regulatory and policy landscape inside as well, in addition to the social licensing to operate. I think these are the steps.
Yeah, that's great. And in some ways, I think when you did the first early discovery, you obviously had a certain crop in mind. And I think the ARC Centre that you've recently had that very large amount of funding for, it's now seeming as though there's a whole range of different agricultural industries that have come on board and really see the potential. And it's, I guess in some ways, when I'm talking about entrepreneurship to students or to entrepreneurs or corporates, we have this thing around product market fit. So you know when you've got product market fit, when the customers are trying to drag it out of your hands, when they're just trying to say, when can we have this? As opposed to researchers or entrepreneurs going out and trying to sell something, and people just sort of looking a bit glassy-eyed and say, well, tell me when it's finished. So it seems as though you've actually crossed that barrier and actually got something that not only horticulture or cereals, but quite a wide range of industries are really chafing at the bit to get.
Yeah, no, it's really grown into, maybe I can establish a Bioclay Institute or something, because wow. we are not only dealing with, as you said, we started with viruses, we are now working on insect pests, and I'm talking about crop plants here, but we are working on fungal diseases. And if anyone is aware of the Australian landscape, we are working with all rural development corporations. So wood innovation, grains research and development corporation, cotton research and development corporation, Vine Australia, Osveg, and not only from crops, but now Bioclays, we are translating it into managing biosecurity risks such as fire ants. We are working on the animal health side of things. We are working on sheep lice and blowfly, and we would love to, there's interest maybe to look at white spot disease of prawns. So the whole spectrum has opened up to take this technology. And as I said, this sort of tells me how you can grow a very small idea that you have into this bigger picture if you have the right way of thinking and the right kind of mindset and learning attitude to take this forward. Yeah, no, it's grown beautifully big, Cameron.
I probably a number of the people watching may not understand the significance of having all of those research and development corporations all wanting to fund the same project, which is quite, and I guess in some ways, what I think is really exciting about that is sometimes when you've got the flexibility and in some ways a bit of a luxury, Neena, to be able to explore how things work and follow some curiosity and doing that, rather than just what we find in corporates is that they're just solving today's problems or maybe tomorrow's problems, but they don't have the capacity to solve next year's problems or next decade's problems. And so one of the beauties of researchers in the university is that they get that opportunity to think forward about how can we actually create a new platform. And that's what you've done. And I think we can create this platform and actually bring a number of those industries into the future with less chemicals, with less pesticides, with less things that are going to not only harm humans but harm the environment. That is absolutely a game-changing approach. But tell me a little bit about, because the discovery, in some sense, and researchers get upset when I say this, but in some ways the discovery is the easy part. The hard part is actually getting it out of the bench, getting it out of the lab, and actually having people in Ethiopia using this on tobacco plants or on cereal crops or on banana plants. What's some of your thinking around how do you envision this discovery actually finding its way out into the world to actually make the difference, as opposed to offering the potential to make the difference?
Yeah, as we were talking about that pathway, from discovery to translation and adoption, and the different cogs that are involved in that pathway, and each one has to be looked at, with great significance and great respect. So in terms of pathway to translation, some of the factors, as I said, as I've been mentioning, having industry on board very early on really helps, because they are the ones who start asking you difficult questions which are not science related. What's the cost going to be? What's going to be the return on investment? What's going to be the hurdles or barriers for adoption? How are we going to be through registration and regulatory landscape for this product? And these are the questions when industry brings in and you start answering them, then your pathway starts getting defined more towards a product development. Like, for example, for Bioclay, there are two components, the clay and the double-stranded RNA. As I mentioned, clay is very cheap to produce. But the first big barrier that we hit, yes, it was working beautifully, but double-stranded RNA was really expensive. We were buying it for maybe $2,000 per gram of double-stranded RNA, and that wasn't going to, reach to translation. But as you start gaining this momentum around a particular idea, you start thinking of these cost factors, and now within the landscape of this topical RNAi, we have companies who are giving quotes. I don't know the reality of it as yet, $2 to $5 per gram. So can you see the change? Of course, you will have to order 1 ton of dsRNA from them, maybe. But this is where the pivots happen and the change happens, which can really break those barriers. And of course, you need to be very much aware of the commercialization landscape and work totally in partnership with that commercialization angle if you really want to take that idea forward.
And do you see there being because everyone gets often very upset about great inventions in Australia, but then the economic value goes overseas. Are you seeing an opportunity here in Australia for there to be an economic value, in terms of activities happening in Australia?
Absolutely, Cameron. This particular, as you mentioned, so this is a biopesticide, so it's safe, it's environmentally sustainable, and clean green image of our Australian produce. That particular brand that we have, that niche that we have, gets strengthened by this particular technology. It does not leave any residue. So that's one side of it, and as I was saying, provenance and safety is really at the forefront of the consumers today, and it ticks those boxes. It ticks those boxes from a trade and export angle as well. If you look at it, any residue-free produce with a non-GM tag has much more value add to it. Plus, runoff to our precious waterways, look at our iconic Great Barrier Reef. We do really need to move towards, and I'm not saying that it's going to replace chemical pesticides, but it definitely will reduce those pesticides. We have those biosecurity risks, fall armyworm. I don't know if anyone is aware of, the crop protection kind of space. We recently had this fall armyworm got introduced into Australia, and that could cause a major havoc. We have Panama disease of banana, as a big biosecurity risk. So definitely, absolutely for the Australian agriculture, this is going to be a game changer. And of course, has its way, A, economic returns to Australia, but B, our reputation as the knowledge leadership providers, as we say at UQ, absolutely that as well.
And do you see there being, in terms of the actual commercialization, once it's got to be made somewhere and shipped somewhere, do you think is there an opportunity for this to be manufactured in Australia and actually have an export industry of the actual product as opposed to just the actual finished products?
I'm happy to state that this it's there. Like New Farm Australia Limited is the industry partner in one of the crop protection areas, and New Farm Australia Limited is an Australian-based company with a global footprint, and they have been our partners in the Bioclay pathway since 2014 now. Long-standing partnership, absolutely wonderful partnership, and I can easily say yes, the manufacturing will happen in Australia. I mean,
excellent. That's very exciting.
That's the concern. Yeah.
No, that's wonderful. So and just I'm going to ask you another question, but for those of you that are watching, if any of you have got any particular questions for Neena, please feel free to drop them down into the Q&A, and between Neena and I, we'll have a look at that. So if you want to ask Neena a particular question, do that. But Neena, I mean, obviously Bioclay is this transformational technology that's got broad application, but that's not all you're doing. You're also working on other things, and particularly the micropropagation. Tell us a little bit about that.
I know, I'm one of those mad scientists, who can't sit still, maybe, so as if Bioclay wasn't enough. So we, just bringing in the word micropropagation, as you have mentioned, and we talked about food security and food supply. But we need to understand that it's not just the food supply, it's the plants supply that could be critical factor as well. We need good plants to give us good food. And micropropagation, as you've mentioned, actually it started with avocados. So believe it or not, I had never tasted an avocado in my life before coming to Australia. So yep, it was a nice journey to fall in love with avocado. And once again, it's a story of pivoting my research. So I was working on managing diseases of avocado, making avocado resistant to diseases. But then when I visited growers in Queensland and across Australia, the problem that they were telling me was that, Neena, that's fine, but we don't even have enough plants to plant our orchards. If we go to a nursery to put an order now for 20,000 or 30,000 plants, the answer is made, put the money now and come back in 3 years. And that made me think, why aren't there enough beautiful avocado plants available? And that whole led to once again, the equation in my mind is always problem driven and not technology driven. Once I understood the problem, then there was this thing, okay, now let's sit down and brainstorm as to what solutions can we provide. So for avocado, if you have to grow it from a cutting, from a tree and make it root, it takes about 18 months to get one plant out of that one cutting. If you grow avocado trees from seeds, the seeds of avocado are heterozygous, they're not true to type, so plants could be different. And this is where an issue was in terms of plant supply, and the seed supply is seasonal dependent. And you have to maintain trees just to get those seeds in. So what we have done is using micropropagation or tissue culture, what we get is 1 millimeter of a cutting from a good tree of avocado. Give it all the tender love and care in our lab, in tissue culture lab, and we can get 500 plants out of that 1 millimeter of a cutting within 8 to 9 months. So that's absolutely, for me, that's the world's first and a game changer for avocado. But what it has done for us is now we are looking forward to translating it into other beautiful tree crops such as macadamias or Australian native foods.
That's great, Neena. And I've just got a question here from Jinendra, who said, are there any existing collaborations with developing economies like India, which will immensely benefit from your research? So are you partnering internationally on this stuff?
Yes. So the answer is yes. We are in the process of developing, we have been having ongoing discussions with India on both Bioclay as well as micropropagation, but specifically on Bioclay. And there are certain Indian industry partners who are either major seed producing companies or the suppliers of the crop protection products with whom we are very actively engaged in discussion.
Great. And Neena, tell me a little bit about where you think research is going, research in Australia, research in universities is going, because it seems as though there's more and more pressure and more opportunity, I guess, for researchers to to think about the translation right at the start. So you obviously have done that in your research, but I guess I get the sense that for researchers to really survive in what is very competitive research field and trying to get money, is you've actually got to think differently about getting your discoveries out into the marketplace. Maybe if there may be some younger researchers listening, to tell us a little bit about how you think that is going to happen, and what is the researcher of the future going to look like?
Oh, I think, that game changing, as we call them, the game changers of tomorrow, the future leaders of tomorrow, they need to be very well equipped in terms of not only having the vision for discovery and that passion and fire to, discover things and apply, but also having that vision and fire for application and making it reach to the ground in close embedding with the industry. And how, at least in my group, Cameron, coming from my own experience, how we do it is, for me, each and every member of my team, starting from an undergraduate who comes just for a winter or a summer research scholarship program to my lab, to an honors student or a PhD or a postdoc, I make it sure that each one of them gets engaged with the industry partner in the project. So if I'm having a meeting with New Farm, let's say in this instance, if the winter or summer research scholar and honors student has worked on that project, I'll make sure that he or she presents to the industry partner. And that face-to-face interaction and close embedding with the industry, sort of, I call it as an initiation step for the researcher, because that sets the scene for their future conversations. And it's been extremely rewarding. I can tell you with one experience, one of the students who was engaged in these discussions when it came the time that we were not having a PhD scholarship for that international student, the industry partner stepped in within one phone call, saying, look, you have already listened to this brilliant student. He's now willing to do a PhD. Would you support a scholarship? And the answer was yes. And that happened because that engagement has already happened. So that's the benefit to the students, but it also gives these young people a taste of the lay of the land, some of the hard things that they need to understand, some of the things that they need to, really value in terms of industry engagement and partnerships. And I think the world, as we are moving forward, the word partnerships is absolutely important. That integration, that partnership, and then synthesis of ideas based on that integration and partnership is absolutely important.
Great, Neena, and I'm just sharing a screen just because I think that's a really nice segue to talk about some of the other things that we've been working on within the business school. So the next series we're going to be doing is on the 18th of September, and I'm really, and you'll be interested in this as well, Neena. This is really interesting. Startup company that I got to know a year or so ago. So Sean Quaid and Veronica Phil are entrepreneurs, and I mean, Sean's a genius chef, and what he's done is he's created a range of plant-based cheese products and dairy products, from camemberts through to fetas and mozzarella. There are a lot of these sort of plant-based cheese products around, but most of them are based on cashew. And the problem with cashew is A, it's expensive, and B, it's not that environmentally friendly because it takes a lot of resources to grow cashew nut. What Sean and Veronica have done is they've started a company based on making cheese out of effectively waste products, things like cauliflower. And fermented vegetable ingredients. And so these guys have just started. They're just a young sort of team that have got together. And what's amazing is that, again, when you look at, if you solve the right problem, then obviously success follows. And so we're going to be talking to Sean and Veronica around how they've now relocated to Los Angeles. They've raised $1.5 million into a startup company, and they just can't keep up with demand. So again, another example of when you solve a really compelling problem, the world will be the path to your door. And so for those of you that are watching, please log into this episode in a couple of weeks' time. And I guess I'd also draw your attention to some of the workshops we're running here at the business school, which is around our executive education program. So we've got courses coming up around designing strategy for results and innovation and productivity for business improvement, and then optimizing influence in negotiation. So we run a lot of these workshops for industry and for corporates. as well as for researchers and entrepreneurs, are really, I guess, around providing some of those basic skills to work out how can we thrive through the decade of disruption. So if any of those things are of interest to any of the people that are watching, please look at the business.uq.edu.au website and have a look at some of those workshops. But Neena, this has been a fantastic conversation. I've been wanting to do this for a long time. So I really love what you've demonstrated to us, which is the future of research, the future of academia, which is not just learning knowledge just for knowledge's sake, which was fine. But we've got too many compelling problems. And I love the fact that you've actually identified some of those really compelling problems. And I also love the fact that you've been able to draw that back to your core central why of even some experiences you had when you were a child. I think that's wonderful to see that drive coming through, and then applying innovation, but also a very flexible approach to commercialization and translation. That's tremendous. So congratulations on the success you have, and look forward very much to hearing about the Bioclay Institute, which would be a great outcome just to see this transformation just grow and expand. So thanks so much, Neena, for your time. It's been a great conversation. For those of you that are watching, just going to put a short poll up on the screen. But please join me in thanking Neena. And Neena, I look forward to seeing you around campus sometime soon.
Thank you very much. Thanks, Cameron.
Great.
Always
Thanks,
nice
everybody.
to talk to you. Thank you.
Great. Okay. Thanks.
Bye.